Telling you is the radius is 14, so PO and OZ is 14. That's all they're telling you, the radius is 14. This angle is 90 here, which is indicated on the diagram. Then it goes further to say, find the area of the field. Now guys, the area of the field, this is just a quarter of the whole circle. It's a quarter of a whole circle. And so the area is just gonna be a quarter of pi r squared. Can you all see that? The area is just gonna be a quarter of pi r squared. R in this case is 14. And we're taking pi to be 22/7. So this is gonna work out to be, put all of this in a calculator, 1/4 multiplied by pi, which is 22/7. Then we multiply that by 14 squared, and that's 154. And so the area of that little field right there is 154 meters. This is a very small field, 154 meters. Then it goes further to says find the perimeter of the field. The perimeter of the field, we can call it P. It's going to be equal to the distance from P to O, which is PO, plus the distance from O to Z, which is OZ, plus the length of the arc PZ, plus the length of the arc PZ. That will give us the perimeter. So the perimeter is actually equal to PO, as we know, is 14, OZ, as we know, is also 14, because they are both radii, plus OZ, plus PZ, sorry. But the length of the arc PZ is theta over 360 times pi r squared. Theta, which is 90 over 360, which is a quarter, multiplied by pi r squared. Theta over 360. If you don't understand where I had this quarter, let me write it out. We're just using the length of an arc formula. It's theta over 360. What is theta? 90. Theta is 90 over 360. 90 over 360. And that's multiplied by pi times r squared. What is r? R is 14. So it's 90 over 360 times pi times 2 pi r, sorry. 2 pi r for circumference. 2 pi times 14. So you can just go ahead and put all of this in a calculator to find what is the perimeter. Put all of this in a calculator. 14 plus the 14 is 28. Plus, area is in meters square. So I'm gonna put that up there. 90 over 360 multiplied by 2 multiplied by 14 multiplied by 22/7. I get 22. So the perimeter is 28 plus 22. 28 plus 22 is 50. Oh gosh, the field's small, man. 50 meters to run around the field. Oh God, you can run around the field in less than 10 seconds. And for the fast athletes, they can run around in less than 8 seconds. You probably cannot say 6, that's for top speed sprinting, but zoops, zoops, and zoops. All right, 50 meters, very, very, very small field. And that's that, nice and easy. Now here it says a diagram below not drawn to scale shows a triangular prism. The cross section is the right angled triangle ABC, where AB is 6 centimeters and BC is 10. Calculate the area of the triangle. Oh gosh, area of the triangle, that's so boring. Half base times height. I like to call area of triangle AT, A subscript T. Area of the triangles are half the base, and the base is 6 times the height. Now the height is this side, but this is a right angle triangle. So we can find the height using Pythagoras Theorem. And so the height is going to be the square root of 10 squared minus 6 squared. And we see that the height is 10 squared minus 6 squared, which is 8. Because Pythagoras Theorem, this height ends up working out to be 8. Pythagoras Theorem tells us that the opposite square plus the adjacent square is the hypotenuse square. That's Pythagoras Theorem. And so a half of 6, which is 3 times 8, which is 24. So the area of the triangle is 24 centimeters squared. That's the area of the triangle, 24 centimeters squared. Nicey. Now that we get the area of the triangle, it asks for the length of the prism if the volume is 540 cm cubed. Now volume is equal to cross-sectional area times length. So the volume is equal to the cross-sectional area times length h. But now this length, the length of the prism, we don't know, but we know the area of the cross-section is 24. And so 24h is equal to the volume of 540. So to get the length of the prism, we just need to divide through by 24 to get h is equal to 540 divided by 24. And that will give you the length. That will give you the length of the prism. 540 divided by 24. So 540 divided by 24, which is 22.5 centimeters. 22.5 centimeters. And that is the length of the prism. 22.5 centimeters. Now it's asking for the surface area of the prism. Now surface area, this is the formula to find surface area. Now surface area of a prism is equal to perimeter times length plus 2 times the end area. That's how we find surface area. Surface area is perimeter times length plus 2 times the end area. The perimeter that we're talking about is the perimeter of the cross-sectional area. The length that we're talking about is this. And then the area we're talking about is the area of the cross-section. All right, so that's how we find surface area. So it's perimeter times length plus 2 times the end area. So the perimeter of the cross-section is 8 plus 6 plus 10. Perimeter is 18 and 6, which is 24. So surface area is 24 times the length. Now the length that we just found is 22.5 plus 2 times the end area. And 2 times the end area is going to be 2 times the end area. And we found the end area already to be 24. So this is the formula that we use to find surface area. And so the surface area of the prism is 24 times 22.5 plus 2 times 24. And that's 588 cm cubed. And that is the surface area of the prism. Nice and easy. There we have it. That's question 6. Soft, capital T. Question 7.